Good morning, everybody. Sorry about the issue we had with the network at school. We tried to log on with cell phones and computers, nothing worked. So I'm moving it to lecturing from home today. Unfortunately, I had a lot of stuff to give you all today, too. I'll give it to you next week, but we'll go over it today. This is day 3. This is the third Saturday of our class. And we've already done sections 1 and 3. In other words, we talked about plotting points, or ordered pairs. We looked at are the ordered pairs a solution to an equation? Remember, so I said, is the ordered pair 1, 3 a solution of the equation 2x minus 3y is -7? So the way to see if this is a solution, remember the first one's x, the second one's y. So in place of x, I put 1. In place of y, I put 3. And I'll work it out. If this is a solution, that means both sides are going to be equal. 2 times 1 is 2, minus 3 times 3 is 9. Nope, not -3, it's -7. 2 minus 9. 9 is bigger, so the answer is negative. 9 minus 2 is 7. Is -7 equal -7? So yes, it is a solution. We've learned how to graph equations. So this we had 2x minus 3y equals 6. We had 2 ways to graph them. One, we used the intercept method. The x-intercept, the first thing we did, since we're looking for the x number, we get rid of the y, set it equals 0. And then solve for x. So first step, since we're looking for the x-intercept, set y equal to 0. -3 times 0 is 0, so it just disappears. Now we solve for x. Divide by 2, so x equals 3. So the x-intercept in our case here, x is 3, and we set y equal to 0. X-intercept always has a y value of 0. Then the y-intercept, since we're looking for the y-intercept, we don't want any x's, so we set x equals 0. Then we solve for y. So again, we set x equal to 0. 2 times 0 is 0, so it disappears. We have -3y equals 6. Okay, and we're going to be doing this throughout. If you ever have a last step, you're solving for a variable, and you have a negative in front of it, don't divide by a negative number. You can, but your chances of making a mistake are very, very, very high, because you're going to have a lot of signs to change now. So what you do here is just, first step is just go ahead and change the signs. That's a -3, make it a +3. That was a +6, make it a -6. Just change signs across the entire equation. every term. Now all you have to do is divide by 3. You don't have to worry about, is the answer going to be positive or negative? It's already determined right there. So the answer is negative. 6 divided by 3 is 2. For the y-intercept, the x value is always 0. Plot the 2 points and connect the dots. That's one way. That's the intercept method. Another method is just find 2 points. We use a table here. Again, our equation is 2x minus 3y equals 6. Besides using 0, 0, let's see what we can find here. So pick a value for x. Let's say 4. Plug 4 in there. Now we're going to solve for y. We're going to solve for y. 2 times 4 is 8, minus 3y equals 6. We have to get the y by itself, so we have to get rid of the 8. So we subtract 8 from both sides. Negative 3y. 6 is positive, 8 is negative. 8's bigger, so the answer is negative. 8 minus 6 is 2. Remember, now we're solving for y. There's no plus or minus left in there, so we change the signs and divide by 3. So y equals 2/3. All right, and we do the same thing. We could pick another value. Let's make it let's make it negative 5. So in this one, we have 2 times negative 5. So positive times negative is a negative. 2 times 5 is 10. Get rid of the 10 because we'll try to get the y by itself. So we add 10 to both sides. 10 plus 6 is 16. Change the signs. So we have 3y equals negative 16. And divide by 3. And that's your y value. So y value is negative 16 over 3. But it's not easy to graph. So again, there is no easy way or right way. It's whatever works for you. Then you just plot, or if one point works, the other doesn't, we could always, there's a third way actually, which we're going to get to into today, is talking about equations of lines. That's a third way using a point and the slope. Remember, we're still trying to graph equations. Find a point on the graph. In any way you want to. If you want to use the intercept method, great. But you have to find a solid point. No fractions, no decimals. Plot that point. put the equation into form. In other words, solve for y. Because if you solve for y, whatever is in front of x is your slope. All right. So first thing, we have to find a point. Let's go ahead and first solve for y. Let's go ahead and first solve for y. Get rid of the 2x from both sides. Negative 3y equals negative 2x and a positive 6. Change the signs. So it's a negative becomes a positive 2x. That's a positive becomes a negative 6. And divide each term by 3. So we get y equals 2/3 x. 6 divided by 3 is 2. If this works out, there's your first point. This, remember, how do we find the y-intercept? If we set x equals 0, then y becomes negative 2. That's called the y-intercept. When you put it in this form, when you solve for y. So y equals mx plus b. This is your y-intercept. And this, whatever's in front of your x, not the x, but whatever's in front, is your slope. So I plot the point at negative 2. It's on the y-axis. Because x is 0, there's no moving back and forth. And I go down 2. Now I follow the slope. Remember, slope is rise over run. Well, rise if it's positive, sink if it's negative. Remember, it goes up if it's positive, it goes down if it's negative. So since that's positive 2 over 3, so I go up 2 and over 3. And I connect the dots, and there's my graph. And we found the distance between the 2 points. The distance formula is d equals square root of x2 minus x1 squared plus y2 minus y1 squared, where x1, y1 are the x and y of the first point, x2, y2 are the x and y of the second point. Just plug them in there. The midpoint between point 1 and point 2 is capital M equals, remember, it's a point. So we have x1 plus x2 over 2, y1 plus y2 over 2. It's the average, the distance between the two. And then the equation, we moved on to the equations of circles, which I call EOCs. the equation of a circle, you have the radius equals x minus h squared plus y minus k squared, where the center is at the point hk and r is the radius. Very careful. If your equation that you're using, if it doesn't have a square root, let's say I gave you this answer, this question. So the center is at these points. And it's always, whenever something's in parentheses, it's always the opposite. So if this is minus 3, so the center part is positive 3. If that's a positive 7, it becomes negative 7. And the radius, since there's no square root, this number is equal to r squared, which means you have to square root both sides to get r. Be very careful about that. And to graph equations of circles, plot C. From C, go up, down, left, and right are units. And draw the circle. All right, and then we moved on to section 3, chapter 1. So here we're asked to determine n given 2 points. Remember, we have 2 points. Each point is made up of an x and a y. Since this is the first point, that's x1, y1. That's the second point, that's x2, y2. The formula is simply y2 minus y1 over x2 minus x1. Slope is also called the average rate of change. So whenever you see word problems asking for average rate of change, it's just a slope. So it's the second y value minus the first y value over the second x value over the x. And whenever you have time in an equation or in a problem, it is always the x-axis, because x always goes to the right, time never goes backwards. So then we were also asked, find m from an equation in the form y equals mx plus b. Remember the slope, once you get y by itself, the slope m is always in front of the x. And the last one. The slope here, yeah, I should give another one. So in this equation, since you already have y by itself, whatever's in front of the x is your slope. Y is by itself, whatever's in front of the x is your slope. Y is by itself, and if there's nothing in front of it, it's automatically 1. Remember, these are always fractions. If it's a solid number, it's over 1. If there's nothing, it's a 1. If it's a negative x, then it's a negative 1 over 1. If there's no x, then it's 0. Because the x is gone. 0 times x is gone. So if you have anything in front of the y, as long as if y is not by itself, get it by itself. Divide each term by whatever the coefficient is. So therefore now once y is by itself, whatever's in front of the x is your slope. Note when you get y alone, the number by itself, no x value, is the y-intercept. Because basically what that means is whenever x is equal to 0, you get this just a constant number. And we're going to talk about today, this is an equation. This is what we call a function. They're the same thing. The only thing that's different is what's in front, and we'll talk about that in a second. All right, now how do you graph a line if you're given m and b? M is a slope, and b is the y-intercept. Plot b on the y-axis from b, follow the slope. If the top number is positive, you go up. If the top number is negative, you go down. And the bottom number is always positive, so you go to the right. So if I was given this, it would have come from this equation, which is y equals m is negative 2/3 and b is 4. That's what it looked like. So I know my y-intercept is 4. 1, 2, 3, 4. So I put that point there. The slope is -2/3. So you go down 2 spaces and over 3. 1, 2, 3. Plot the points, connect the dots, and you're done. All right, so today we're going to start on section 2, because now we're going to start talking about functions and domains and ranges. Before we move on, we have to first talk about the difference between a correspondence and a relation. And you could relate it back to humans and how we associate with other people. If you're in a relationship, you have one person, call them A, they associate with only one person, B. They can have other friends, but they have a relationship with one person, only one person. In other words, they call that person and text them all the time. A correspondence is one person here can correspond to multiple people. We call this one-to-one. It's a one-to-one relationship. It looks like this mathematically. Whenever you see that, that means one person from the first group or one item in the first group correspond or has a relation with only one element of the second. In the first group, we'll call that X. Relates to one and only one element in the second group. We'll call that group Y. A correspondence. In the old days, correspondence is what they used to call mail. Education. You used to take classes, like if you were a soldier or if you were in some business company that put you at far places, your education was by correspondence, which means they send you some homework, you do the homework, you send it back to them, they grade it, send you some more. That's correspondence. So here's in a correspondence, here's one teacher, they correspond with a whole bunch of students. This is not one. This is one to many. And in math books, you'll see it this way. Here's group A. Here's group B. You have elements inside there. So this is A, B, C, D. 1, 2, 3, 4. Now, in set A, these are my X's. Does element A have a relationship or a correspondence with any member over here, and the second group, which is the Y group. Since this person here, this element, only connects only one here, that's a relation. Likewise with B. B only has a relation with one element over here. So that's also a relation. C, yep, only one here. So that's a relation. But D has a correspondence. So back in the old days, the mail, if you had a circular or the old Sears catalogs, Sears would send out the catalog to everybody. That was correspondence. The person may shop only at Sears. They have a relationship with Sears. So it all depends on which way you're going. A could have a relationship with B. B has a relationship with A, but A has a correspondence with all these. Here's another way we can look at it. If I had points, are these points, do they form a relation or do they form a correspondence? Right, or correspondence. Because if you look at, remember, each of the x's can only, for a relation, each x can only relate to one y. So each x, as long as the x's are different, it's okay. But if the x's are the same and the y's are different, it's not a relationship. Okay, so the only thing you have to look at, are there any similar x's? If there are any similar x's and they have different y's, then it's a correspondence. But since the y's are the same, that's a relationship. If all your x's are different, then you have a relationship. The only time we have to worry about it is if two or more of your x's are the same. If you have the same x's, but different y's, then it's a correspondence. If same x's and same y's, then relationship. So that's what you have to look at. Just in a list, just look and see if you find any two x's are the same. If they're the same x's and different y's, then it's correspondence. If it's the same y's, then it's relationship. That's all you really have to look at. All right. Now, So a relationship is 1 to 1. And this will become important in a second. All right. Let's talk about functions. Another way of representing an equation. The equation is going to be the same. What we're now going to use, instead of the letter y, we're going to use this notation. This is the function name. This is the variable in the function or the equation. Because a function is the same thing as an equation. So this x inside whatever is inside the parentheses is the variable in the equation or the function. It's read f of x. The function name, the variable name. So in the past, we had this 3x plus y equals 3x plus 2. I'll say find it if x equals 3, x equals 0, and x equals -2. So from here, you would have to do 3 times 3, y equals 3 times 0, y equals 3 times -2. So anywhere I see an x, I put those values. Then I work them out. 3 times 0 is 0. 0 plus 2 is 2. Positive times negative is negative. 3 times 2 is 6. Opposite signs, 6 is bigger. The answer is negative. 6 minus 2 is 4. Okay, we solved those, but what do they mean? Again, we're talking about x and y's. And when we talk about x and y's, we're talking about a chart, a graph. Since I defined x and I found y, I found a point. X was 0, y is 2. When x is -2, y is -4. We could do the same thing with functions, though. So the function f of x is 3x plus 2. It means anything I put in the parentheses goes in place of x. Anywhere I see an x, I put whatever's there. So this is how I would ask these questions. First off, it's a lot easier than writing than that. And what this one says is go to the function f, which is this. Anywhere I see an x, I put a 3. Go to the function f. Anywhere I see an x, put a 0. And lastly, go to the function f. Anywhere I see an x, whatever's inside the parentheses is my x, it replaces the x in the equation. Positive, negative is negative. 3 times 2 is 6. 6 minus 2. Again, these are also points because here's my y value. This is y is the same thing as f of x. So in the past, when we talked about a point is x and y, it's more accurate because here I'm saying that the x I use is corresponding to this y value. Here, as x and y doesn't seem to have any relationship. So this one says, whenever I use an x, I put it in the equation and I get this value. Here's my x is 3, my y is 11. X is 0, y is 2. X is negative 2, y is negative 4. That's what it tells us. And we graph it the same way. Remember, this is the same thing as y. So I plot the y-intercept at negative 3. I follow the slope. I go up 2 and over. So I go up 2 and over 3. From that point, I go up 2, 1, 2, 3. And connect the dots. Right, so that's what a function is. Now, how can you determine if a function, no, I got that backwards. Determine if an equation is a function. I was going backwards for a second. Remember, in order to be a function, for each x value, there can be one and only one y value. And this is always true for linear equations. So there could be, for each x value, there's only one y value. So let's look at it backwards. If I want this to equal 4, let's solve for x. I pick a value for y. Let's see if it has more than one x value. Subtract 2. And then divide by 3. So x is equal to 2 over 3. There's only one value, so it's a function. All right. How about a graph? So let's draw some examples of graphs. So let's look at these. Is this one a function? For the way you check a graph, it's much easier for a graph. For every x value, if I drew a vertical line, does it touch the graph only once? Because if it only touches only once, that's only one y value. So yes, this is a function. Same thing here. I keep on drawing vertical lines, and it only touches it once. Yes, it's a function. Same thing with this one. Yes, it's a function. Uh-oh. There's a vertical line. We hit it twice. No, not a function. Same thing here. No, not a function. These equations also have names. This is a linear equation. Quadratic equations. This one is a cubic equation. A circle. Hyperbola. It goes that way. It's the same as this, but it goes that way. This equation looks like this. This equation looks like this. So that's the difference. So to determine if it's, we did all these vertical lines. The vertical line test says this. If you draw a vertical line through any point on the graph, it can only cross the graph once. That's the vertical line test. In other words, I drew a vertical line to any point on the graph, it only crosses the graph once. Except here, I drew a line through that point, but it crossed the graph again. I drew a graph through the line of that one, I got that one. So that's the easy test if you have a graph. And we know how to graph already, so. All right, next is we're gonna use the same pictures. We're gonna use the same pictures. But this time we're going to look at something else and determine possible values of x and y. We call those domain and range. The domain are all possible x values that can be used in the equation without causing it to fail. Okay, the domains are the inputs. We also call those independent variable. It's the x values. So the domain deals with the x values. What do I mean by fail? Here are two examples. On this, with fractions, when x is on the bottom, you cannot have a 0 on the bottom. That's impossible. The only way a fraction can equal 0 is if the top is equal to 0. A fraction equals 0 is if the top is equal to 0. Inside these are called radicals. Okay, these kinds are called rational equations because they become a ratio. Radicals are these square roots or nth roots. It could be a third root, it could be a fifth root, it could be a fourth root. You can't have x cannot be negative. Because you cannot take a square root of a negative number. So those are my domains. So it's what these are looking for restrictions on the x values. That's what the domain stands for. The range is once we find the domain we can use, the range is just the other end. Are all possible y values that can result from the x values. These are the outputs. These are called the dependent variables. These are the y values. So the range deals with all possible y values. Let's look at these. Yes, I use those specific ones because it spell out the word count. So here the first numbers, we're gonna look at the domains. Now for domains, I'll use letter D, and for range, I'll use letter R. So the domain in the first one. To determine the domain and range always starts from the lowest, go to the highest. So this on the x-axis, the smallest it can go is 3, now -3. and it goes this way, since these arrows point, it goes to positive infinity. We use a bracket because, yeah, it can equal that value. So we put a negative bracket next to F3. You can never get to infinity, so we put a parenthesis there. And the range, where's the lowest it can go, since it keeps on going forever and ever and ever, it can keep on going all the way down to negative infinity and always up, all the way up to that. So it can go from negative infinity to positive infinity. It keeps on going up and down. We call, whenever it's negative infinity, positive infinity, we call that all real numbers. So there's the first one with the hyperboloid. With the circle, the domain, look at the x-axis. What's the farthest left it goes? -2, and it stops at +2. Can it equal those two? Yes. Likewise, what's the lowest it can go? -2, and the highest, positive, and it can equal those values. So there's that one. How about this one? The domain, left and right. Again, these arrows are going forever and ever up and out. It's not going straight up, it's actually going out like this. So it's going from negative infinity to positive infinity. You can write either one of these. You can write that, or you can write that. They'll both be the same thing. It means all real numbers. Now, vertically, the lowest it can go is at -2, and it keeps on going up to positive infinity. This is a cubic function. You notice these go on forever and ever and ever. So it goes from negative infinity to positive infinity. Or likewise, it goes down and it goes up. So it goes from negative infinity to positive infinity, or all real numbers. It's a horizontal line. This is a graph of a constant number. It's a horizontal line. We'll talk about this in a little bit. The slope of this one is 0, and it's a horizontal line. So what's my domain? It crosses at 3. So on the x-axis, it goes from negative infinity to positive infinity, or all real numbers. But the y-axis, it only crosses at one point. It doesn't go up or down any. So there's that. All right, so that's what section 2 is all about, domains and ranges. Section 4. Equations of lines. Actually, before we move on to there, there's something I wanted. Again, if we would have had class in class today, we would have had, I would have given you these, because I want to talk about because we're talking about functions here in section 2. We'll hold off on section 4. We want to talk about functions. So here's a graph. I'll give you all one of these. Oh, if you want this is already online. This is what we call the library of functions. In high school, they call it the parent functions, but parent functions of parent. There's only two. No, a library has many of them. We actually have 12 functions to talk about. These are the basic functions where everything develops from. The first function we have is called a linear function, linear equation. Linear equation is just that. It's a line. Like for example, y equals x. When x is 1, y is 1. When x is -3, y is -3. So the domain for this one is from -infinity to +infinity. Likewise, the range is the same thing. It's the all real numbers. Remember, these are the same thing. This is a little bit different. It's also a linear equation, but which a linear equation simply means it's a line. So it draws a straight line. This one draws a line also, but it's of a number. For example, let's say y equals 3. It's a constant function. So if y equals 3, there aren't any x's, so no matter what x you give me, it's always going to be this. So the graph of a constant function, if I have y equals some number, it's always a horizontal line. The domain is all real numbers. The range is only at 3. In this case, it's y equals whatever the value is. Okay. Let's look at the absolute value function. We're going to have a whole section on this later on in the course that deals with absolute values. So what exactly is absolute value? Whatever's inside there, positive or negative, the absolute values make it positive. Right? So, and it's, notice there's no exponents. You notice on linear equations, there aren't any powers, any square roots. It's not a fraction. So if there's no special operations or exponents, those are lines. That's a line. On the positive side, it goes like this. When x is 1, y is 1. When x is 3, y is 3. If x is -1, y is 1. When x is -3, y is 3. So let's check that. So whenever you see an absolute value, it's going to be a v. The domain from -infinity to +infinity. And the range, the smallest it can go is 0, because the absolute value of 0 is 0, and it keeps on going up to +infinity. So we have that as the range. The greatest integer function, this is one of the special ones that are out there. And it's called the greatest integer because that's all it deals with. No matter what you put in for x, if you put 0, it equals 0. If you put 0.5, it becomes 0. So here basically is drop the decimals. It's called truncating. Whereas if you have a number like 0.4, just drop anything decimal and it's a 0. So it's going to stay this way. It's going to stay 0 till you get to 1. Then at 1, it jumps up here. It stays 1 until you get to 2, and then it jumps up here. And likewise, it goes all the way. It's also called the stair-stepper function. It's a stair step because it looks like a stair step. So the domain is, it goes on because every one of these lines are connected. It stops here, it starts here, it includes that one. It goes to here, but as soon as it gets there, it jumps there. It jumps there. It jumps there. So this one goes from negative infinity to positive infinity. It's all real numbers. But since the y values can only be integers, we use the symbol for integers. Only integers. All right. The quadratic equation is quadratic because it has a 2 there. Now, no matter what, can you put, if you put a negative in there, like a negative 3 squared, this means negative 3 times negative 3, which is positive 9. If you put negative 2 in there, you get positive 4. If you put negative 1 in there, you get 1, you get 0. It looks like a line, but it's a curve. In other words, the answer y can never be negative. If you put a negative number there and square it, it always becomes positive. So the domain is all real numbers, and the range, the lowest you can go is 0, and then you go up from there. Because if the power is even, if the exponent is even, this can never be negative. But if it's odd, in other words, negative 2 cubed is negative 2 times negative 2 times negative 2. Negative negative is a positive, positive times negative is a negative, so it's a negative 8. So the answer, if the x is negative, the y is negative. If the x is positive, 2 times 2 times 2, the y is positive. So here's an exaggerated way this one looks. Right? So the domain, it keeps on going forever, both directions, so it's all real numbers. And likewise, the range, it goes all the way down, it goes all the way up, so it's all real numbers. Okay, the other side, radicals. This is called a square root. The reason it's called a square root because it's invisible that there's a number 2 in there. And we'll talk about how to find all these, what they mean. The only limitation here of a square root, of a radical, if it's an even, we call that number the root. Root, R-O-T, O-O-T, like a root of a tree. If it's even, this, the x has to be greater than or equal to 0. So that's our domain. It could be 0 or it goes on forever. But the range, since it's only positive numbers I have in there, it comes out to be positive, so it's going to be the same. So it means, basically what it means is whatever number is inside X, since that's a 2 there, it's a square root, what number times itself gives me 4? 2 times 2, so it's 2. Once you have a pair of numbers in a square root, you can take it out. That's why square root of 25 is 5 times 5. Since I have 2 of those, it comes out. So what this one looks like is like that. Because when x is 1, when x is 0, y is 0. When x is 1, y is 1. When x is 4, y is 2. When x is 9, y is 3. When x is 16, y is 4. So it builds up really slowly. The domain, it starts at 0, goes to infinity. Now notice if you can use the value, I put a bracket. You can never get to infinity, so it's a parenthesis. Likewise, with the range going up and down, the smallest it could be is 0, and the largest it could be infinity. This is a cube root. Remember, that number in that V area is called a root. Cube is 3. So what this one looks for is what number times itself 3 times equals 8. 2 times 2 times 2. But now, since we have an odd root, this is odd, I can have a negative in there. Negative 2 times negative 2 is positive 4, times negative 2 is negative 8. So the answer is, so the cube root of negative 8 is negative 2. So we have the same type of graph on the positive, but we also have, if x is negative, y is negative. So it looks like this, like a very flat S. The domain is all real numbers, so it goes from negative infinity to positive infinity. And the range, it goes down forever and up forever. Now we talk about rationals. Whenever we talk about rationals, these are fractions. Fractions with x on the bottom. The only rule we have here is x cannot equal 0, because you cannot divide by 0. So when x is very small, when it gets close to 0, here's 1. When x is 1, 1 over 1, the answer is 1. When x is negative 1, 1 over negative 1 is negative 1. But when x is getting bigger than 1, that means this whole fraction, 1/5, 1/10, 1/100th, 1/1000th, it gets smaller and smaller and smaller and smaller. But the closer x goes to 0, if it's a fraction, it becomes an integer. It becomes bigger. So our graphs here look like that. It never touches the x or the y axis. So my domain, this thing goes on forever to negative infinity, but it gets very close to 0. But I never touch it, so I have to put a parenthesis there. And it starts the same thing on the other side. It gets very close to 0, and it goes on to positive infinity. We use the U as a union. Which means my answer can be here, or it can be here. Likewise for my range. I can come from negative infinity all the way close to 0, And then I got to take a break and go up to the other side. It go from close to 0 to positive infinity. Remember, always in these parentheses, it always goes from the smallest to the largest. Smaller to larger, smaller to larger. That's 1 over x. Now, if we have a rational equation that's got an even exponent, 1 over x squared. Remember, whenever you square something, it can never become negative. Negative 3 squared is negative 3 times negative 3, which is positive 9. So on the positive side, it does the same thing. So as x gets bigger, it goes down to 0. Likewise, from the negative side, if I put a negative 1,000,000 there and I square it, it's going to be positive, but it's going to be all the way down there. So it looks like the Atari symbol. The domain here, remember, we go from negative infinity, get very close to 0. We can't go to 0, so we have to skip that. It could start, the next group goes from 0 to positive infinity. The range, let's look at the y values. What's the lowest? Can it become 0? No, it gets very, very, very close. It keeps on going down, 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 down. So it gets very close to 0. But it goes all the way up to infinity. All right, now for the exponentials. Exponentials mean that the variable is the exponent. So this number here is called the base. And that's the exponent. On these type, the x is variable. A couple of things have to be true here. B, the base, has to be bigger than 1. Because if it's negative, x can be positive or odd or even. So if it's even and b was negative, it would change from positive, negative, positive, negative. It would oscillate. It would go up and down, up and down, up and down, up and down. So we have to restrict b to being positive, and it has to be greater than 1. There's another condition for this when b is between 0 and 1. And I'll show you what that one is. Because again, these are going to have its own sections to discuss. So since b has to be positive, no matter what you give it, it's always going to be above 0. So you have no values down here, no negative numbers. And it can never equal 0 because any number raised to a power can never be 0. So what this one looks like is like this. And it always, 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 always crosses at 1. Because anything to the 0 power is 1. So this is with b being greater than 1. If b is between 1 and 0, then it goes down. And it crosses at 1, though. But again, we're going to talk about this in chapter 5. So don't worry about too much about it. The domain and the range. Domain is all real numbers because it goes from negative infinity to positive infinity. The range, it gets very close to 0, and then it goes up from there. And that's the same for both of these. Logarithms, again, they're going to have their own section, the whole chapter. They're the opposite of exponents. Since in this one, it goes from negative infinity to positive infinity, crosses at 1. crosses the y-axis at 1. These do the same, but crosses the x-axis at 1. So the domain, it can never get to 0, so it goes from 0 to positive infinity. It's going this way. It's always going to positive. It's never going to touch the x-axis here, so it never gets to 0. And the range goes from negative infinity to positive infinity, which is all real numbers. So this is what we're going to use from now on out when we start dealing with functions. Because we're going to do transformations in the next chapter, and you have to know what the basic function looks like. And that's where we resort back to this one. All right. We'll do one more section, do equations of lines. This first off. Well, let's look at three types or forms of lines. First one we call the point slope form. It looks like this. Y minus y1 equals m x minus x1. It's called a point slope because it has a point x1, y1. So these are the values from the point, and it has a slope m. Once I give you that stuff, plug in those three areas and you're done. The second is the slope intercept form. This is the traditional one everybody talks about when they think about lines. They'll always say y equals mx plus b. It's called a slope, which is the m, and the y-intercept, which is the b value. The third is called the standard form. Standard form shows that the x and the y's are on the same side and equals some number. The only difference here is a has to be positive. So if you get an equation that looks like this, is that in standard form? You have x and y on one side and a number on the other side. It looks like it, but a is not positive. A is whatever's in front of the x, and b is whatever's in front of the y, and c is about a constant number. Since that's not positive, we have to change everybody's sign. So -3 becomes +3, +2 becomes -2, -5 becomes +5. This is in standard form. Now, the way that they all happened, all three forms came from this slope equation. y2 minus y1, x2 minus x1 equals m. There's a slope equation. So the first thing we want to do is isolate the y values. There's also another thing. Whenever you have fractions, you want to get rid of the fractions first. How do we do that? By multiplying by the denominator. Whatever the denominator is, multiply both sides by it. So this and this cancel. So we get y2 minus y1 m x2 minus x1. Since we're given a point, x1, y1, and the slope, we don't need x2 and y2. Notice we don't need this. We don't need the subscripts actually. So this becomes y minus y1 m x minus x1. And there we have it. There's the slope, point slope formula. We're given a point and a slope. So again, since we're given a point and the slope, let's pretend we're given a point and a slope. Let's say we're given a point 1, 3, and the slope is 2. Remember, this is x1, y1. So we get y minus 3 equals 2 x minus 1. Solve for y. First off, we have to get rid of the parentheses. 2 times x, 2x. Positive times negative is negative. 2 times 1 is 2. Add 3 to both sides. Negative 2, positive 3. 3 is bigger. 3 minus 2 is 1. And there's our equation. This puts us into the slope intercept form. Because once we start off with the point slope formula, if you're given a point and a slope, you get the slope intercept form. That one was 2x plus 1. Get all x's and y's on the same side. So we subtract 2x from both sides. Minus 2x plus y equals 1. Make A the coefficient of x greater than 0. Make it positive. Change the signs. I get 2x minus y equals -1. This is now in standard form. So that's how they all get derived. So now let's look at, that's if I give you a point and a slope. So if I gave you a point and a slope, where's that one? If I give you a point and a slope, I could plug it into here and here, like I did there. I plugged in the point in x1, x2, or x1, y1, and I put slope in m. If given 2 points, find the equation of the line, which I'm going to call EOL from now on. Well, let's see the ones we had earlier. You have to know, first off, what form. If no form is given, if no form is specified, then y equals mx plus b. That's usually the go-to form. First thing you have to do, we have to find the slope. y2 minus y1, x2 minus x1. So x1 is 1, x2 is 5, y1 is 1, y2 is 4. y2 minus y1, x2. Get in the practice of always writing down your formula you're going to use and deal with, because it'll decrease the amount of mistakes you can make later on. So y2 is 4 minus y1, x2 minus x1. So our slope is 3/4. Now choose either of the points x1, y1, or x2, y2, doesn't matter which ones. For this example, I'm going to use the first point. Plug your slope and the point into the point slope formula, and solve for y. The point slope formula is this one. So I have y minus 1 equals 3/4 x minus 1, which is x1, y1. Get rid of the parentheses. 3/4 times x is 3/4 x. Positive times negative is negative. 3/4 times 1 is 3/4. Now add 1 to both sides. So we have minus 3/4 plus 1. We have to have common denominators. So this one needs a 4. So we need to multiply 4 over 4. The easiest way, since we have a common denominator, just add the top. 4 minus 3 is 1. And there's your equation of the line. Okay, that's using the formulas. Let's look at another way of doing this. Using the same, we're going to use the same point. Well, we use the same points, 1, 1, 5, 4. Here's an alternate method. To find the equation of the line mx plus b. Given 2 points. Find the slope. Y2 minus y1, x2 minus x1. So 1, 1, and 5, 4. 4 minus 1, 5 minus 1, so we get 3 over 4. The same way we did last time. Here's where it gets different now. Well, we do this also. Choose either point. Again, I'm choosing 1, 1 because that's x1, y1. That's makes me it's easier. So I'm going to use the point 1, 1 and the slope 3, 4. This is where it gets different. Plug into y equals mx plus b. Plug into it already because we have x, y, and m. The only thing we need to do is we need to find the y-intercept. So y is 1, m is 3/4, and x is 1. 3/4 times 1 is 3/4. When we get b by itself, so we have to subtract 3/4 from both sides. So it equals 1 minus 3/4. Again, we need a common denominator, so it's 4/4 minus 3/4. We have a common denominator. Worry about the top. So b equals 1/4. Then all you do is plug your m and your b you just found into the y equals mx plus b. This is step 4. So y equals, your slope is 3/4 x, and your slope is 1/4. You have to leave x and y because that is for all the other points. There's your equation. So that's how you find equations of lines. All right. Now, if we have two lines, well, actually, we'll talk about this in class next time. All right, everybody, good luck, and we'll see you next weekend.